Hi. Um, this lecture is going to be about element inventories so we can make progress towards getting to balancing equations. Something I want to mention, and I'll mention it again later when we start balancing, is this is something called a polyatomic ion. And that's a group of ions that functions together as a team and never breaks up during a chemical reaction. And the benefit of knowing about these is when you're doing a chemical and element inventory, you of course can list magnesium and phosphorus and oxygen, but sometimes you can include these as a group, and then it's easier to just count these as one, or in this case, two, because you have less things to count. Okay, so you can always break them apart, but if you only have to count up two groups of things instead of three, or sometimes it's four or five or six, that makes things a lot easier. Okay, so we'll talk about polyatomics again later so you can see the difference between how much easier it is. So we're going to talk about element inventories. So a lot of this is just review, so I'm going to proceed fairly quickly because you've already seen this. So a chemical equation is a chemical change. The reactants are what we start with, the products are what we end up with. And we've already seen that. Now, this is how we're going to think of it differently. More specifically, when we're balancing equations, we need to know that the number and type of atoms going in is the same as the number and type of atoms going out. Okay, so we can't create something or destroy it. What we start with is what we have to end up with. It can just change the combination of how they're put together. Very much like the law of conservation of energy in physics. And if an equation is balanced, it is obeying the law of conservation of matter or mass. Okay, when it's not balanced, it's violating that law. All right, so this is an example of an unbalanced reaction. So here's the equation, and here's kind of a picture version of it. We can see there's only one carbon on both sides. That's okay, that's balanced. But how many green hydrogens are there? There's 4 here, and there's only 2 here. And then the red oxygens, we've got 2 and 1, 2, 3. That is not balanced. What goes into the reaction is not what comes out of the reaction. So this is what we're trying to figure out, what to do, how to balance that. Okay, so we would balance it by putting numbers in front. So we change the coefficients. So eventually we're going to get to the point where you are doing that. And if we look now, we've got 1 carbon. That's still good. We've got 4 hydrogen. 1, 2, 3, 4 hydrogen over here. 1, 2, 3, 4. 1, 2, 3, 4. So now what goes into the reaction is what comes out of the reaction. It is balanced and it follows the law of conservation of mass. All right, so just a little quiz for you. Is this balanced or unbalanced? How many carbons? 3. How many carbons over here? 3. How many hydrogens over here? 8. How many hydrogens over here? 2 times 4 is 8. How many oxygens? 2 times 5 is 10. And you might say, well, the oxygens don't balance, but we have 4 times 1 oxygens, and then 2 times 3, which is 6. What's 4 plus 6? Hey, it's 10. This is, in fact, balanced. How about this one? Is it balanced? How many iron? 3. How many iron over here? 1. So you could stop right there. It's not balanced. If even one atom is not balanced, it would be not balanced, and it violates the law of conservation of mass or matter. Okay, so now if it's not balanced, what are we going to be able to do? And that's eventually what we'll talk about when we balance equations. So I'll give you the rules, but we're not going to get to balancing equations yet. We need to figure out how to do one more thing before we can start balancing equations. So you know how to count atoms using the coefficients and subscripts, and there's still one more thing that we have to do before we can balance equations. So There's 4 rules. Really, there's just one. So I kind of have, this is the law of conservation of matter or mass. You cannot change these subscripts. If you change the subscript, you've caused a chemical reaction and it's something different. So number 3 is honestly, this is the only real rule. The only thing you can do when you're balancing equations is change the numbers in front. Okay, so you can't put a number in between, you can't change the subscript. All you can do is change the numbers in front of the chemical formulas. Okay, so like all of these, especially like 2 and 4, they're kind of like reminders about what you can't do. You can't change a subscript. You can't put a coefficient in between a chemical formula. You can only put it in front. Okay, so really, number 3 is the only thing that you really need to remember. Okay, don't do this, and you have to follow this. All right, so this is what our next kind of objective is how do we do an element inventory to figure out if the equation is balanced or not? So, and I'm going to show you how to do this in some examples here. So if it doesn't quite make sense, that's okay. The first thing you do is make a table. I like to make the table right underneath the yield arrow or in the middle of the equation because that helps me keep my reactants and products separated. After you make that table and you're going to list all the different atoms, count up how many of each atom is on the reactant side and how many of each atom is on the product side. Okay? And then you can ask yourself this question, because if the answer is yes, then you're done. Is it balanced? Okay, so if it's balanced, you're done. If it's not balanced, then eventually you're going to have to do something about it. But for right now, we're just worried about doing these element inventories. So what do you think here? In your notebook, if you don't want to rewrite this equation, at least write this list of elements. Do you see how it's right under the arrow? And you wouldn't even have to write this stuff. I would just list the elements, okay? So how many irons are there over here? How many irons are over here? You would list that for the iron. How many oxygens are on both sides? And you would list that in the oxygens. How many hydrogens? You would list that here. So I hope that's what you got. Okay, so we've got 3 iron, 4 oxygen, 2 hydrogen on the reactant side. And on the product side, we have 1 iron, 2 hydrogen, and 1 oxygen. Let's try another one. Okay, so in your notebook, if you don't want to write down the equation, at least list nitrogen and hydrogen. How many of each are on the reactant side and how many of each are on the product side? Do you see by listing those underneath of the arrow, it just really keeps things organized. So hopefully, so pause it and figure that out. Hopefully you got 2 and 2, and then over here it's 1 and 3, right? Okay, so here's another example. This one's a little bit more complicated. So in your notebook, list your, all we have here is carbon, hydrogen, and oxygen. So make a list. It's a little bit off center here. Sometimes you have to do that. So pause and count up all the carbons, hydrogens, and oxygens, and carbon, hydrogens, and oxygens. For the reactants, I hope you got 2, 6, and 2, 2, 6, 2. That makes sense. Now be careful. Be careful with oxygen. 1 carbon, 2 hydrogens. How many oxygens? Well, there is 2, but don't forget about this oxygen. So sometimes I like to write it like that. So I remember, oh, oxygen is in 2 different places. All right, and that is, we're going to stop there and give you some practice in element inventories before we start balancing equations.